Hey there, hi there, ho there. Let's finish up, excuse me, the pre-Cambrian, shall we? So, last time we talked about the Hadean and the Archean, mostly the Archean. Now we're going to get into the Proterozoic Eon. All right, so this unit's going to be tiptoeing around this section of time from about 2.5 billion years ago to 541 million years ago. And you'll hear me refer to the Paleoproterozoic, Mesoproterozoic, Neoproterozoic. Paleo means old. It's the old part of the Proterozoic. Meso means middle. It's the middle part of the Proterozoic. Neo means new, the newer part of the Proterozoic. But still, very, very old. It still is a pretty big chunk of time. So we're going to cover almost 2 billion years worth of information, which covers 43.1% of Earth's history. But again, it's the older we go back, the less evidence, rocks, fossils, etc. So we should be able to get it done in one unit. Okay. So some highlights from the Proterozoic. We start to get the rise and fall of supercontinents. More on that in this and following units. The beginning of several major glaciations occur. The atmosphere changes drastically during this eon. We get the rise we start leaving single-celled only life. We start to get the rise of multicellular life, which takes over. Sexual reproduction, passing on DNA traits. And we get the very first animals, finally. Oh my goodness. So now at the boundary between the Archean and the Proterozoic, geologists kind of just arbitrarily placed the boundary at around 2.5 billion years. It's not like a hard line, something exactly happened there. It just, excuse me, marks the approximate time of changes in the style of crustal evolution. So plate tectonics kind of changed a little bit. And again, it's about the approximate time because Archean type of crustal evolution was not completed at the same time in all areas. So what are we talking about here? When we're in the Archean, the crust formation was heavy into that granite gneiss complexes and greenstone belts that were eventually accreted, smushed together to form cratons. This process still continued somewhat into the Proterozoic, but it did so at a very reduced rate, much less than what occurred in the Archean. So that's kind of what marks the difference kind of between the two. They said, well, this kind of crustal evolution's more so back here, so let's just call this thing the Archean, and let's call this other thing the Proterozoic. By this time, many Archean rocks have been metamorphosed, but you get vast exposures of newer rock in the Proterozoic that's unaltered or nearly unaltered. And in many areas, you get Archean rocks are separated from Proterozoic rocks by an unconformity. Right, weird things happening, missing information. There's some big gap in time between these Archean rocks down here and these Proterozoic rocks up there. Additionally, what we're also starting to see is widespread associations of sedimentary rocks during the Proterozoic Eon. These are going to be located at passive continental margins that are not near a plate boundary, so there's not really a lot tectonically going on, so that allows whatever's there to kind of weather and erode, deposit sediment that would lithify to turn into sedimentary rocks. So we start to see that process occurring, and it's pretty much the same that's occurring right now, the similar processes. Kind of some other differences between the Archean and the Proterozoic. Proterozoic, more so a time of evolution atmospherically, biospherically, as well as the origins of certain natural resources. Again, oxygen-dependent organisms evolved during this time. That's because atmospheric oxygen begins to increase. More on that in a later section. Again, first multicellular life and animals appear. the fossil record in the Proterozoic Eon is poor compared to the Phanerozoic, which is the last 541 million years of Earth's history. But it's there. Something's there. How the continents of Earth evolved during the Proterozoic. Again, going back, the Archean consisted of a lot of cratons assembled during the collision of island arcs coming together, and little mini continents, little mini cratons, to eventually form the bigger nuclei, the bigger craton, around which now in the Proterozoic additional crust is going to be accreted, added to, therefore making, for example, the North American craton much larger, as well as other places. Excuse me. When I talk about this kind of stuff, this is happening all around the world. The examples I use, though, are usually from North America, if not the United States, if not Arizona, if I can, just to make it a little bit more relevant. The accretion that occurred, adding on material to the existing cratons, probably took place more rapidly than today, because again, there was still a little bit more heat left over, and so plates were moving a little bit faster. So this accretion process was a little faster than it would be today, but nothing staggering. Again, we're still in the Precambrian, so at least in the United States, there's not a lot of exposed Precambrian rocks just hanging around. Oh, excuse me. But today in this unit, we will definitely be talking about things like in this area over here, and a number of other places. Tell you what, before I go, let me go ahead and give you the first part of the super secret code. It is the number, 4. How about that? The number 4. Let's start off with lucky number 4. So let's pause there. When we come back, we'll talk about kind of forming and kind of the main body of the North American craton known as Laurentia. So we'll pause here, and I'll see you back here in just a second.